In today's lesson, we'll be looking at how to test for right-angled triangles. We previously explored that if a triangle is right-angled, then that allows us basically to use c squared equals a squared plus b squared, which is the Pythagoras theorem. But if we say that this is actually true, so the Pythagoras theorem actually holds, then that means that the triangle is right-angled. So we're used to going this way, but now we're going back the other way, which is what we call the converse of the Pythagoras theorem. Okay, so converse means just the opposite of what was previously done. Okay, so look at this example. Test whether each triangle is right-angled. So we're firstly going to have a look at what C is, AN, and B is. So C is firstly our hypotenuse, and we're going to try and find out C squared. So you remember how in our formula we've got these two sides. We're going to find what this is first. So C squared in this case is 45 squared. Now if I simply type that on my calculator, 45 squared is the same thing as 2025. But now if I test out the right hand side, which is this side, a squared plus b squared, we'll have the 27 squared plus 36 squared. Okay? So if I type that on my calculator, 27 squared plus 36 squared also gives me 2025. So what do we actually notice then? We actually notice that this, which is c squared, is equal to a squared plus b squared. These two are the same results. So that means we can say that since the Pythagoras theorem works on these triangles, then this angle here, just between the shorter sides or opposite the hypotenuse, that has to be right-angled. So we can say, therefore, the triangle is right-angled. Okay? Now, if we focus on the next question, we can see that the longest side is 15. So we can say that is the hypotenuse for now. Okay? And then A and B can be randomly given to the other two values. So let's find out what C squared is. C squared is going to be 15 squared, which is 225. And if we do A squared plus B squared, which is 6 squared, plus 14 squared, 6 squared plus 14 squared is equal to 232. So let's now have a look at what these are again. This is our c squared, whereas this one was our a squared and b squared. Well, the two results that it gave us are not identical. So that means that c squared is not equal to a squared plus b squared. And what that tells us is the triangle is not at right-angled. Okay? Alright, so just to summarize again, if c squared is equal to a squared plus b squared, the triangle is right-angled. If they're not equal, like how we have in question B, then the triangle is not right-angled.